Okay, so our warm-up is to solve and graph a multi-step inequality. Okay, so it's not looking too bad. Hopefully you watched a little video just as a reminder, but some of it, or hopefully a lot of it, is semi-familiar. The nice thing is you solve it the same exact way you would solve an equation. So that's always nice to not add any new steps in there. When I combine like terms, that gives me that. And that when I subtract 6 will give me x is less than or equal to 6. Okay, so nothing too terrible or even different from what we were doing before with equations. The only new thing is now we have an inequality, so greater than or less than. So we need to kind of keep that as we move down. And I also need to graph it. You don't need to do anything fancy for the graphing. I literally just put a 6 there. So you can put a few other numbers around it if you please. The main thing I'm looking for is the number is there. You have the correct symbol. If it says less than or equal to, that or equal to line is going to tell us that this should be a closed circle because we are including that in our answer. And then you need to shade, and that says less than, so you can do anything you really please, but I'm gonna shade to the left. Some people do like an arrow, I don't really care as long as I can tell in which direction your answer is. So technically, 6 is not the answer. The answer is 6 and everything below it. So 5 is an answer, 4 is an answer, negative 26 is an answer. So there's not just one answer for these. That's why you do have to graph that. Does anyone have a question with that one? Okay, so I'm going to give you some trickier ones today, and then we'll look at some compound stuff, which is all kind of based on the same thing. So if you're getting this, you should be okay. But I just like to show you some different ways that things are set up. So we'll do maybe like 2 together. You guys will try 2, and then we'll just kind of see how we're feeling. If you ever don't understand something, please ask. So let's see. Let's do a tricky one. Let's do 5. Actually, you know what? I feel like this is always the trickiest. And this was on your last test, so let's see how you did. X plus x plus x minus x minus x minus x is less than x minus x minus x minus x minus x minus x. There was something like that on that assessment, and I said a lot of people really make little mistakes. So let's see if we can solve this one. So I see it and I just say, oh, it's kind of weird looking. But really all we have to do is combine like terms on the left and the right side. So let's do it on the left side first. I just kind of go through and say, oh, there's all x's. So x plus x is 2x. Plus x is 3x. Minus x is 2x. Minus x is 1x. Minus x is 0x. So basically those just all cancel out. If everything cancels, you put a 0. That freaks people out. Zeros, people don't like them. It's okay. If there's nothing, we represent that with a 0. On the other side, let's see what we got. X minus x is 0. So that would be negative 1, negative 2, negative 3, negative 4x. So this is not a special case. I feel like when people see zeros, they want to write like no solution and stuff like that. If you still have a variable, you can keep going. You don't just stop, and you only have special cases when everything cancels and there's no variables left. So in this case, I would technically divide both sides by negative 4. 0 divided by negative 4 is 0. So that is my final answer. 0 is less than x. And I put this in that little video just to remind you, when we read inequalities, we really try to read them. I know we like to read left to right, just out of how we read in general. But when we read them, you want to read them from the variable. So this one we actually read backwards. We would read this as x is greater than 0. If that freaks you out because it's backwards, flip them. And if you remember back in the day, you know, your little alligator, your little Pac-Man, whatever, if the alligator is eating the X, when you flip it, you just do that. I feel like people tend to like this way better. It just makes more sense in their head. So always feel free when it's backwards, you're like, oh, I always get confused. It says less than, but it's really greater than variable. Just flip them. Not a big deal. And then from there, you would graph your answer. Once again, it doesn't have to be too fancy. I'm just throwing the 0 on there. So the big thing I'm looking for is what type of circle is it? In this case, since it says x is greater than 0, and there's no or equal to it, is an open circle. So technically, we're not really including 0, which is kind of where we're starting. And then it says x is greater than, so you usually shade to the right. And that will be your final answer. So little things, one, don't get freaked out if there's just a whole bunch of variables. Do your best to combine like terms as much as you can. If you get zeros, that's okay. That doesn't make it a special case. You just still continue to solve for x. Getting a 0 as an answer is fine. And then just if things are backwards, feel free to move them around or just read them a little bit differently so you're okay. Does anyone have a question with that one? So I always just try to point out things that, I've been doing this for 15 years. In general, people tend to make the same like little mistakes, and that's something that people tend to do. The 0 thing, they like to put no solution, and then if things are kind of mixed up, they tend to maybe graph it incorrectly. So I'm just trying to show you, so hopefully you do not make that mistake in the future. Any problems? Anyone need this? Oh. All right, let's try this next one. Once again, I'm trying to kind of show you things that I've seen people make mistakes on. Let's do -5 x minus 6. We won't make it too crazy. Is greater than or equal to 16. I'm making it really easy. So other things, once again, I made a little video of it. I'll assume that you watched it, but maybe you didn't, or maybe you just flipped through it quick. So another thing I wanted to point out to you, that doesn't look too bad. It's just a 2-step inequality. I start to go through and kind of solve. I'm solving the same way I do with an equation. 1 second, I need 22. I divide, okay, so I'm just doing my normal steps, but this is where you need to kind of like, a little alarm needs to go off in your brain, because anytime you multiply or divide by a negative number, you have to flip your inequality. So this has to flip the other way. Unfortunately, it's just one of those things you have to be on the lookout for. There's no like hint at the beginning. You just have to kind of watch for it. It happens randomly, every now and then it'll happen. But just as a reminder, anytime you're multiplying or dividing by a negative, you have to flip your inequality. So you can notice that originally started as a greater than or equal to, and I flip it to a less than or equal to, and then end. I'm graphing based off my answer. Once again, if you just like literally throw negative 22 over 5, I'm fine with that. If you want to figure out what it is well, what would that be? -4 2/5. If you want to put it in between two, go for it. I don't care too much about the exact where it is. I do care. What symbol are we putting there? We are putting a closed circle. And then which way are we shading? We shade based off the answer, and we did have to flip it, and that is a less than. So here's where people sometimes make a mistake. You have that rule in your head, and you're like, okay, multiplying or dividing, if there's a negative, and sometimes this will happen. So let me just show you the difference. 2x plus 6 is less than or equal to -12. Okay. So, okay, you just start a problem. You kind of just go through the motions here. Subtract 6. 2x is less than or equal to -18, and I divide by 2. Sometimes people tend to be like, well, this is a negative, so that gives me -6, so I should flip it. But your rule says we only flip if we're dividing by the negative. So since you're actually dividing by a positive, so the 2 is the one that you're moving is positive, that will stay the same. Sometimes people just see negatives, they just start flipping everything, they get all sorts of excited. You only flip if when you multiply or divide, the negative that you're multiplying or dividing by is negative. So having a negative answer is fine. You don't have to do anything with that. In that case, you would have -6, close circle, and that's it.
Isn't it -9?
That's totally negative. Yeah. I don't know why I was dividing by 3 in my head. Thank you. Totally. Always, yeah, always makes sense. So just some little things that pop up. I want to do one more with you, and then I'm going to have you guys try a few before we do compound.
Mr. Chairman,
Oh, what's up?
may I go to the bathroom?
Absolutely, just grab a pass that.
Okay.
All right, one more I wanted to do with y'all. Let's do 2 times x plus 3 minus 6 is less than or equal to x minus 12 plus x plus 6. All right, I'm just gonna make numbers up there, but I go and I'm saying, all right, I'm gonna kind of organize this like I would an equation. I'm gonna simplify either side, and then I can kind of start to move stuff. So on the left side, I can distribute. I can combine like terms. 6 minus 6 would just cancel, right? So you can write 2x. If you want to write 2x plus 0, go for it. So it's just kind of how you prefer to write things. I keep my inequality there in the middle. And then I can simplify the other side. So when I simplify over here, I get 2x. Negative 12 plus 6 is minus 6. All right, so I'm just kind of going through what I know how to do. At this point, I want to get my variables together. So pick one, doesn't matter, I'm going to pick this one, and I'm going to move it over here. What I notice happens is it cancels. If you have nothing on this side, we represent nothing with 0. And I'm left with that. So this is a special case. The reason being is because we have no x's left. So there's a big difference between x and 0, or there's just no x's. In this case, there's no x's. You really do have to pay attention to your inequalities, because with equations, it was like, oh yeah, they're not equal, it's no solution. With inequalities, you have to actually think of the numbers. So we're just saying, is this true or not? So this is saying, is 0 less than or equal to -6? That's not true, right? It's not less than. So that would be no solution. To graph a no solution, you do nothing. There's no solution. Let's just say, just for fun, if the answer had come out to this, that statement is true. 0 is greater than or equal to -6. I just wanted to show you that would be infinitely many solutions. So once again, they don't have to be necessarily equal. It's just that statement has to be true. And you can graph infinitely many solutions. That just means that every single point, either way, is an answer. So that's the difference in the two special cases. Once again, these things, like as you're doing problems, it'll just be kind of random and be thrown in there. So something to look out for, a special case is when your variables cancel, so you have no variables left. You're seeing if the statement is true. If it is true, it's infinitely many solutions, and you kind of fill in everything on your graph. If it's not true, it's no solution, and obviously if there's no solution, your graph is kind of just layered. So we did the little video, but I always like to remind you guys of things in person. As of this moment, are there any questions? Okay. Once again, you've probably seen it. You have seen inequalities. I'm going to be honest with you, but you probably saw them like last, I don't know, fall. So it's been a year. Inequalities are something that do pop up for us quite a bit. We use inequalities later in the year as well. So it's one of those things in math. We'd rather understand the basics now so that we do the more complicated stuff. Life is a little bit easier. So I'm going to have you, I'll just give you 2. Can you please try these 2? You're going to solve and graph your answers. Let's see what we will. Let's do. 1 is less than or equal to. Okay, here's number 1. And how is number 2? Let's do something with, yeah. I don't really want to do that. Okay, so you're just trying those two once again. I like to kind of give you a little bit of practice, but as I kind of just quickly look back, I'll look back a little bit more detail later. It looked like people were okay with that in Math Excel as well. All right, so we're gonna go over these and then we're gonna look at things that are compounds. So we'll remind ourselves what that means and what it looks like in terms of inequalities, because then what we do tomorrow with absolute value inequalities is kind of based on that. So we just see a bunch of stuff going on and I say, all right, I'm gonna have to do a little simplifying, move stuff around, see what happens. So we would get 5x minus 10 plus 6x minus 1, and I'm just gonna continue to kind of work with this side. I'm gonna say that gives me what, 11x minus 11? Okay. And then on the right side, I'm doing the same deal here. So I got 12x minus 3 minus 10, which would be 12x minus 13. So there's two things that can happen. You have to pick a variable. You can decide, I'm going to move this over here. That will give you a negative, which means I'll have to divide by negative. Doesn't really matter, just something to be on the lookout for. Or you can move your variable over here, where some people don't like when the variable's on the right side. So it's just preference. I'm going to move my variable to the left. Whichever way you prefer, it doesn't matter because we're going to get the same answer. I get negative 1x minus 11 is less than or equal to negative 13. Okay. I go through my solving steps. I get negative 1x is less than or equal to negative 2. I am dividing by a negative, which means I am flipping my inequality, and x would be greater than or equal to 2. So just as a heads up there, as you're rearranging, sometimes you may get negative x or negative coefficients. When you divide, make sure you flip that. Or you could have rearranged the other way and it would have just said 2 is less than or equal to x. And you just kind of take care of that from there. And then from there, we got a 2, closed circle, and then we are shading based off of my answer, which is greater than. Are there any questions with number 1? How we solved it, how we simplified, how we graphed anything? Fabulous. Number 2, combine like terms, I'll get 2x minus 9. On the right, I distribute. And I would get 2x minus 17. And the less than in between. I get my x's together, but what I notice is as I move them together, they cancel. And then we're just saying, is that true? Negative 9 is less than negative 17. That's not true. Negative 17 is less than negative 9. So this would be a no solution. And you can't graph it. So if it was an assessment and there was a graph, you would just put nothing on it. So that's kind of opposite. But what I always want to do before we move on is just make sure you guys are okay. So are there any questions at the current moment on just if I said to solve an inequality? No. Okay. So we'll just do one quick thing with compound because then it kind of goes into tomorrow too, which is fine. And then that's it for today. Not too shabby. Okay, so when I say something is a compound inequality, write it first. Right. I always remember back to like my elementary school days. I still remember this lesson. I can visibly remember it was like maybe third grade, and we were talking about compound words. And we had to clap for some reason. I don't know why. So like a compound word is, why can't I think of any examples right now? Baseball, ice cream. What's another compound word? Why can't I think of zero word? Compound word?
Rainbow.
Oh, rainbow. That's a good one.
Football.
Football. Basically, a compound word is when you take two other words and make a new word, right? So I don't know why we did the whole clapping scene, but I was into it. I still vividly remember that. I don't know why. So if a compound word is when you combine two words to make something new, a compound inequality is when we combine two inequalities to make a beautiful new one. So what you're going to notice for compound inequalities is you have two inequalities. So here, there's kind of two setups, so let me show both of them to you. Here's the first setup. So we would say that's a compound inequality because we have two inequalities, maybe not that problem. So with a compound inequality, our main goal is to still focus on the variable, try to isolate the variable, get it by itself. To do so, we would have to do some rearranging. So I go to this middle section and I'd say, okay, I need x by itself, so I would add 1. So the main thing you have to do is if you do it to the middle, you gotta do it to the right and to the left. That's the main thing for compound inequalities. Whatever you do to one section, you have to do to every section. So we would get 3 is less than or equal to 3x is less than or equal to 6. And then once again, still trying to isolate x, we would divide by 3 in the middle, on the right and on the left. And now we get 1 is less than or equal to x is less than or equal to 2. So that is what your final answer would look like. I kind of solved the same way, it's just now instead of doing it to the other side, I have 2 places to do it rather than 1. You do need to know how to graph these. That's the big thing. I feel like the solving is kind of like, okay, I solve like normal. But you need to know what that says and what it means on a graph. So on a graph, I'm gonna put 1 and 2. I'm gonna put a 1 here and a 2 here. I know those are gonna be on there at some point. So think about what this is saying. We read it from the variable. This is saying x is greater than or equal to 1. Okay? So at 1, we're gonna put a closed circle and we're saying is greater than or equal to. I'm just gonna kind of do it there and then I'll show you the other part. And it's saying x is less than or equal to 2. So I'm gonna put a closed circle here and I'll do that. And our answer is there where their shadings meet in the middle. Yes.
So it says 3x minus 1 is less than 5, but why does it?
Oh, I don't know why I just magically came up with the or equal to. Thank you.
Not bad.
Should be an open circle. That's just because I went crazy. Sometimes we'll do that, especially on a Monday. Sorry, I just changed it magically. Don't do it. So keep your inequalities. Whenever you do to the middle, do to every piece, because there is more than one now. And the big thing is that you can actually read what that answer says and graph it. So there are 2 pieces. In that case, since it's greater than 1 and less than the other, it kind of meets in the middle there. Any questions on what? Okay, let's do the other setup, and then I'm going to show you a little bit more of a complicated problem. And we'll probably be done. Let's say we have 2x plus 3 is less than or equal to 7. Or x plus 6 is greater than, sorry, I need to make sure this makes sense. So that one was kind of unconnected together. We call that an and problem. because one thing is happening and the other is happening at the same time. Or we can have an or problem where two different things are kind of happening. So let's just solve them and kind of see what happens, because they're separated already, which is kind of nice. So basically I just solved this inequality. I would get 2x is less than or equal to 4. So x is less than or equal to 2. Let me solve that pretty quick. I'm going to subtract here. I get x is greater than 4. So we have two answers. We put or in the middle of them. So now let's kind of see what the heck does that mean on the graph. I know on my graph I'm going to have a 2. I'm going to have a 4. This says x is less than or equal to 2. So close circle, less than. X is greater than 4. Open circle, greater than. Anytime you have one or the other, they're not going to meet. So, and anytime you have or, they should be going in opposite directions, just as a heads up. But that's your other type of compound. Inequality. And there's one more that I need, except I just can't remember it off the top of my head here, so let me find it. I wanted to show you a fancy one. Oh gosh, it requires me to know where I kept the fancy one. Compound inequalities. Sorry, sometimes if I make things up, it's just a real hot mess, so I'll try to make this not terrible. That requires my computer to work. Okay. Ooh. Well, guys, tomorrow's pajama day, so if you didn't partake in America Day today, feel free to partake tomorrow. Not a bad day to join in for the school spirit. I'm about to smash my computer, so if anyone I'm just gonna pretend that that's not happening, and I'll just do this. Really? Sorry, I'm like, okay. Let's see if I can find it. Sorry, technology is not my friend today, so let's see if I have a printout of what I actually need. Why do I trick stuff? What's happening? Oh, this is my trick notebook. Oh my god, I'm losing my mind. Losing my mind. Are you joking me? I don't know my answer. Sorry, bear with me. This is not my friend today. I just need this one. Maybe. Alright, this is the one, not the next. Okay, here we go. Let's finally find it. Sorry about that. They would be mean to me. Okay, so here's my problem. Minus 2 is less than 8. Okay. All right, I just wanted to show you this one because I feel like half of you look like you're bored / asleep. So this will make your life more exciting. We have this compound inequality. I know it's compound because I see 2 inequality symbols. So okay, always good to kind of just know what you're getting yourself into. So I say, well, my main goal is to isolate the variable, but now I'm confused because there's variables everywhere. Whereas the last one, I was just like, you have that nice little variable, you were just moving stuff around. So that's a little confusing. So we need a way to set up a problem when this happens. There's kind of too many variables going on. There's no way to really isolate them. I guess I can keep moving them around, but that's not gonna help. So if you see this happen, you are going to kind of do what we did in the other one. It was split into two. We're gonna do the same thing here. We are going to look at this inequality, and we're just gonna take these two. We would get 3 minus 4p is less than negative 15 minus 2p. Basically what happens is a lot of times, and this happens in math a lot, when you're trying to do three things at once, it's hard. Like it doesn't make sense, things aren't combining. So if you're trying to do three things at once, maybe break it down and just do two at a time. That's kind of the main goal here. So basically what we do is take those first two inequalities and kind of, we'll do that separately. And then we would take this over here and split it up and take these two inequalities. So you are using the middle one twice, but that kind of makes sense because if it's in the middle, it's related to both of them. And you would do it there. So now it's going to be a little bit easier to solve because we can get our p's on the same side. You can do it however you please. I'm going to move this way this time. You know, some people like the left. Whatever you like, go with that. I'm going to do a little bit more solving, just moving stuff around, which is way easier now that we're only dealing with two parts. And I'm going to divide. And I get p is greater than 9. So the actual solving wasn't bad, nothing different than what we've been doing with normal equations. It's just it was really confusing when I was trying to do kind of three things at once. So then I basically split it up and now I have another inequality. The middle stayed the same because the middle is related to both of them. And then we just dealt with the right side. So let's get our p's together. Move this way this time. I always try to kind of like to keep things positive. Whatever works for you, go for it. And then I'm just solving like a normal inequality or equation. What does that give me? 1333. So p is less than 30. Nope, p is less than 11. God, I'm lucky. So what we would do, okay, we had a compound. We had to kind of split it up because things were a little messy. But we do have one answer. So the answer is the p is greater than 9 and less than 11. So we would write our answer like that. And the graph, you would have 9, you'd have 11. They would both be open circles. When they're connected like that, we say and, so they're happening at the same time. So p is greater than 9 and less than 11. Those types will always kind of meet in the middle. We'll talk about that more tomorrow. So that's kind of as fancy as they get. Hopefully you've been following, and it's nice that all the steps are the same, but sometimes with the setup, something funky might be thrown in every now and then. So thank you for bearing with me while my computer hated me, but that was the type of problem I wanted to show you. So here's the plan. Tomorrow we're doing absolute value inequalities, which is actually just a type of compound inequality, so we'll kind of base off what we did today. And then we will have a little bit of practice at the end of class tomorrow, just before you leave, because your 2 assignments at the end of the week will be based off of this stuff. And then we'll just continue with inequalities next week. So we still have about 3 minutes left, so if you can just hang out for the 3. You can ask me questions if you have them. Now's a good time.